This lesson is on populations and random samples. So the essential question for this lesson is how can you determine whether a sample accurately represents a population? So first of all, we need to understand what is a population. And so that's this first blank here. Population, let me fill this in, is an entire group of people or objects. So when you're talking about a population, you're talking about a big group. A sample is part of that population. So let's say you wanted to ask a question of a group of people, for instance, who they were planning to vote for president. It would be too difficult to ask everybody in the whole country. So what you do is you take a sample. And the key thing here is you want your sample to represent the larger population. All right, so you can use a sample if it's a good random sample to make what's called an inference, inference or conclusion about a population. So there's some information you're trying to get about the population, but you can't get it from the entire population, so you use a sample of the population. So when a sample is selected at random, each member of the population is equally likely to be selected. Now, this is really key in this topic. To have a good sample, every person or thing in the population has to have an equal chance of being chosen for the sample. If your sample excludes anyone or anything by the way that you do it, then it is not a random sample. So here's a couple things. You want to know the favorite extracurricular activity of students at your school. Determine whether each method will result in a random sample and explain your reasoning. So the first one says you ask members of the school band. All right, now keep in mind, the important thing is here is what is our population? And so you want to know the favorite extracurricular activity of students at your school. So the population is all of the students at your school. So for it to be a random sample, every student at school has to have a chance of being selected. So the first one says you ask members of the school band. Well, the answer is no, that is not a random sample because students that weren't in band didn't have a chance to be selected. So you've eliminated some people from being chosen. You publish a survey in the school newspaper. You could argue yes or no on this one. Um, so everyone has access to the school newspaper, right? Maybe everyone doesn't read the school newspaper, right? That would kind of lead you towards no, it's not random. But the thing is, as long as everyone has an opportunity to read the school newspaper and answer the survey, then it is a random sample because you're not excluding anyone. This is assuming everyone has access to the school newspaper. Now, let's say the school newspaper costs money and some people couldn't afford it. Well, then it would not be random. But I'm going to assume the school newspaper is free and everyone has the opportunity to access it. You ask every eighth student who enters the school in the morning. Again, this could be yes or no. I'm going to say yes, assuming that you're getting all the entrances to the school. All right. So everybody had a chance to be selected because they're all walking past you and you just picked every eighth student. That's random, right? That's a random sample. Everyone had a chance to be chosen. Now, if for some reason there was another entrance that you didn't cover, then this could be a no. You ask students in your gym class. That's a no because if the students aren't in your gym class, they didn't have a chance of being selected. So here's the key takeaway here. For it to be a random sample, every person or thing in the population has to have an equal opportunity to be selected. If you exclude anyone, then it is no longer a random sample. So this is a Venn diagram showing the idea here. The big circle is your population, and the sample is just a piece of that population. So it gives you a visual perspective of what we're talking about. Population is the big group, sample is just a small piece of that. So here's some more examples. A new power plant is being built outside of town. In each situation below, residents of the town are asked how they feel about the new power plant. Determine whether each conclusion is valid and explain your reasoning. So again, what's our population here? The population is residents of the town. So keep that in mind. That's important. In all these types of questions, the first thing you want to do is determine what is your population? What's the big group you're looking at? So the local radio show takes calls from 500 residents. The radio station concludes that most of the residents in town oppose the new power plant. So did every person, every resident of the town have an opportunity to participate in this local radio show? The answer is no, because not everybody listens to that station. I probably listen to radio stations that you don't listen to, and you listen to some that I don't listen to. So unless you played it on every radio station, which still there's might be people that don't listen to the radio at all, right? So you're excluding anybody that doesn't listen to the radio and doesn't listen to that particular radio station. So this is not a random sample. So it's not a valid conclusion. A news reporter randomly surveys two residents outside of a local supermarket. The reporter concludes that the residents of the town are evenly divided on the new power plant. Well, a couple things here. They only asked two people. For a good random sample, you need to ask a decent number of people. What's a decent number? It depends on the size of the population. And we're not going to get into that much detail in this lesson. But two is clearly not enough people to ask. And the other problem is they ask people to a local supermarket, and there might be more than one supermarket in that town. And so you've excluded everybody that doesn't shop at that local supermarket. So again, if you exclude anybody from the population from being selected, then the answer is going to be no. It is not a random sample. And then this last one here, I guess it's not the last one. You randomly survey 250 residents at a shopping mall. You conclude that about twice as many residents in the town are against the plant than are for the plant. So you looked at residents at a shopping mall. 250, that's a good number. But does everyone go to that shopping mall? And the answer would be no. So if there's anyone that doesn't go to that shopping mall, you've excluded them by doing it at that shopping mall. So hopefully you can see it's actually really difficult to get a good random sample. One common way is to take like a phone book, which I guess phone books don't exist anymore, but the phone numbers of all the local residents and randomly choose some. Even that's not perfect because maybe some people don't have a phone, right? So it's difficult to get a perfectly random sample. So this next piece says a blank blank is not representative of a population. One or more parts of the population are favored over others. Or the other way you could say this is some people were excluded. And so the term for this is a biased sample. So if not everyone has a chance of being selected, then we call that a biased sample. And an unbiased sample is one where everyone does have a chance to be selected. So unbiased sample and random sample really mean the same thing. So if the sample is not random, then we can also say that it's a biased sample. So it's really two different ways of saying the same thing. So here's another example. You want to estimate the number of students in a high school who ride the school bus. So here's our population, students in a high school. And we want to estimate the number of students in the high school who ride the school bus. All right, so our population is not students who ride the school bus. Our population is students in the high school. And we're trying to estimate the number that ride the school bus. So the first one, you choose 4 students in the hallway. The next one, all the students in the marching band. 50 seniors at random. 100 students randomly selected from the school directory. All right, so the first one, it's not enough people, and you're only doing it in this one hallway. So that's no good. B, you're only looking at students in the marching band. So anybody who's not in the marching band, you excluded. They weren't part of the sample. Didn't have a chance to be part of the sample. C, you just looked at seniors. So you left out all the other students in the school. So the correct answer would be D. So a school directory is just a list of all the students in the school, and you just randomly pick 100 names. So everybody in the school's in the directory, so everyone had a chance to be selected. The last slide here, what makes a good random sample? Use the following situations to support your answer. So situation A, you want to know how often teens rent videos. You plan to survey teens going into the local video rental store. So your population is teens, all right? That's your population. Do you survey teens going into the local video rental store? Is this biased or unbiased? Well, your question is about renting videos. If you choose teens that are going into a local video rental store, then you're much more likely to get answers of, you're more likely to get students, or I'm sorry, get teens who rent videos because you're at a video rental store. So this is definitely a biased sample. So you wouldn't want to interview or ask teens that are going to a video rental store. You want to ask teens randomly throughout the community. Situation B says you want to know the most popular breakfast cereal. You plan to survey every fifth person entering a grocery store. Is this biased or unbiased? Well, the first problem here is we don't really know what the population is. It doesn't say, is it all the people in the town? Is it just the people going to that grocery store? So let's assume that the population is people that shop at this grocery store. So if you survey every fifth person entering the grocery store, that would be a good random sample. So I'm going to say that it's unbiased, but I'm saying that based upon the population is just people that go to this grocery store. The last one says you want to estimate the number of calories that the average American eats. So here's your population, Americans. So the average number of calories they eat each day. Explain how you could collect valid data about this topic. How would you select your sample? So this is the hardest one there is. If you're trying to do all of America, again, the most common way is there are government um, data collection places for driver's license and home ownership and all kinds of things like that. And so what you typically would do is access some sort of database and randomly select people to do the survey. All right. The hard part is getting a list of all the Americans to randomly choose from that. It's virtually impossible. All you can do is do your best. And so you'd want to have every state included. If you just did one state, that would be biased. So hopefully that was helpful to you. If so, give it a like and a subscribe. And until next time.